We've all been there. You chain a dot filter to a dot map. Maybe even throw in a dot for each for fun. It feels clean, but you're making 3 trips through your array. I mean, that's totally fine for smaller datasets, but what happens when you get a huge array that you need to parse through? What if I told you one single array method could do all of this work in one pass? It's time to talk a little bit more about reduce, the quiet powerhouse of JavaScript. We touched on reduce in a previous video, but let's dive in a little bit deeper. Check out this shopping cart. We want a total for just the items that are in stock. The classic approach, we filter through the items, grab the ones that are just in stock, and then we map over them to grab their price, and then we add it all up. This is exactly what we did in a previous video. Looks slick, I get it, but you've just looped over that array more than one time. For small arrays like this, no big deal. For a big array, that's more work, that's more memory used, and you're just clogging up the event loop for no reason. Let's take a look at a mini example. Now, reduce does look kind of funky at first. I mean, what's going on here? But it's simple. I promise it will click. Reduce takes 2 values, a callback and an initial value. Your callback gets 2 main things: the accumulator, which is the value that you're building up, and the current item in the loop. You can think of the accumulator as a snowball. With each item in the array, the snowball gets bigger and bigger. Whatever you return from each iteration in the loop becomes the snowball for the next loop. So back in our cart, instead of doing a filter, a map, and a reduce, let's do it in the reduce only way. And that would look like this. We would do cart.reduce. Our accumulator would start off as 0, and each item in the array is represented as item. So what we're doing is we're checking that the item is in stock, and if it is, we're adding its price to the accumulated value. Look at that. No extra arrays, no loops, just one clean trip through the data. And the best part, your snowball doesn't have to be a number. You can build up an object, an array, a map, whatever. The for each method is another one that we can replace. Since it doesn't return anything, you have to declare a temporary variable to manage the state outside of the loop. Let's say we want to log each item that's in stock and get the total. The old way would involve creating a temporary variable, we'll call it log total, outside of our loop. So we could map through this, check that it's in stock, log out the product, and add the total to the price, or add the price to the total. But with reduce, we can handle the logging and return the final total all at once. And that would look something like this. We can call reduce just as we did before. And inside of our callback, we can check that the item is in stock. If it is, we can add its price to the accumulator and return that value. If it's not in stock, we can return the accumulator as is for the next iteration. No more defining variables in the global scope. Everything is contained in this one operation from start to finish. All right, here's where reduce really earns its rule them all title. Let's say we have a set of users that looks like this, and we want to group them by their age. You can't do that with a simple filter and map chain, but with reduce, it's totally doable in one pass. We would call reduce, as we do normally, and we create a key based on whether or not the user's age is greater than or equal to 30. If it is, the key is senior. If it isn't, the key is junior. And then inside of our accumulator, which starts off as an empty object, we create the key and we push the user's name. This syntax here is called a ternary operator, and it's something that I'll be happy to cover in more depth in another video, if that's something you guys want. And just like that, you have a complex data structure. You can't do that with the other guys. Flattening arrays, counting things, finding the min or the max, it's all the same pattern with reduce, just a different snowball. All right, let's be real for a second. Is reduce the fastest method ever? No. In a raw speed test, a for loop will probably beat it. But are you really going to notice that difference in your UI? Probably not. The boost in readability is worth the tiny performance hit. Look, if you're processing 1 million items and you want the absolute fastest, go ahead, run your benchmarks. But for the 99% of us that want to be able to understand what the code is doing 6 months from now, reduce is the way to go. If your brain is already buzzing with ideas on what you can refactor with reduce, do me a favor. Go ahead and hit that subscribe button. I drop deep dives like this every week. I've got a little challenge for you. Go to one of your projects and find where you're chaining map and filter together. and refactor it to use reduce. Drop the before and after in the comments below. So think about it. Map gives you a new array, filter gives you a smaller array, and for each just does stuff. But reduce can do all of that and plenty more in a single pass. Once you master this idea of the accumulator being a snowball, you'll write cleaner code, you'll loop way less, and wield some JavaScript that almost feels like a superpower. So next time you automatically reach for filter and map, just take a second and remember, there's one method to rule them all. I'll see you in the next one.